afternoon Sustainability Lunchtalk. As usual, this Lunchtalk is recorded and will be uploaded on the Sustainability webpage in the coming days. Please be aware that we will not take questions during the presentation, as a dedicated Q&A moment will take place at the end. If a question pops up during the talk, feel free to write it in the chat. My name is Mathieu Gilleron, and I'm project manager in sustainability for the University of Luxembourg. With my colleague Laurent, one of our missions is to raise awareness on sustainability among the community. To help us, we have the chance to be surrounded by brilliant experts from teaching, research, or administration. And from time to time, we even go to our neighbors. And today we are happy to welcome Dr. Jean-Baptiste Burnet from the Luxembourg Institute of Science and Technology to talk about, so that's the tough part for me, cyanobacterial blooms, or what we call blue-green algae as regular people, I guess. But apparently, spoiler alert, they are not algae, and I just learned that. So very disappointed that Jean-Baptiste and Silvia have been letting me written algae everywhere, but they are not algae actually. But apparently even the experts are using this word. So last year, while working on the Sustainability Lunchtalk program, my colleague and I thought that talking about water quality and more precisely the issue of the blue-green algae would be a perfect summer subject. Too bad summer has not reached Luxembourg yet. But all joke aside, those algae, which are not algae, are the perfect example of climate change, being both the causes and consequences, leading to an endless loop. But even more interesting is how experts are monitoring and treating them. As you will see and learn during this talk, it's a mix of long-term and short-term solution, of nature-based solutions and reduction. It's a cooperation between experts. Our host for this lunch talk is Dr. Jean-Baptiste Burnet. He is working as a research and technology associate at the LIST. His research has been focusing on source water protection and quality monitoring in a context of safe drinking water supply, and he is currently involved in developing an integrated framework for cyanobacteria monitoring in water bodies using latest technological innovation as well as through active involvement of citizens. Every time it's the same for me reading those descriptions. Our co-host for the day is Dr. Silvia Venditi. She is a research fellow at the Department of Engineering of the University of Luxembourg. She is nowadays specialized in nature-based solutions applied for the removal of micropollutants in rural and urban areas, or for decentralized treatment of wastewater in general, with the ultimate scope of reusing water and reducing its scarcity. We are very excited to have them both today. And without further ado, Dr. Venditi, the floor is yours.
Thank you very much, Matthew. So I will share my screen. Which screen you will see? Maybe not the right one. 1 second. Yeah, here it is. Can you see everybody my screen? Yes. So hello, everybody. It's a pleasure for me to host this talk, especially because of the presence of Jean-Baptiste Burnet from LIST, where I have been working some years ago and where I continue to have a good relation. The topic of this talk is about these cyanobacterial blooms, and as Matthew kindly introduced, they are not algae. And why we are saying that? But because when we think about blooming, we have in mind this. So I was collecting some of the old dramatic newspaper in Luxembourg, because we are dealing with this issue since 20 years. What are the blooming algae? We read here blue algae alert in the Upper Sur Lake. Nice picture of green. It's quite picturesque to see this green in the water, but it's also very dangerous, and it's an alarming issue. And why we get to know about this blooming is because we cannot bat in the sewer. We cannot have our recreation wreck during summer. So this is the main point for us as humans. Why these algae are appearing in summer and why they are not algae? They are the cyanobacteria that are developing in the water, and there are factors that are that they are favoring their development in the water. These factors are input of nutrients like nitrogen and phosphorus they are mainly coming from the human activity. So you can have discharge of runoff from agriculture, but also overflow from urban areas or rural areas. In summer, we also have a much more warmer water, and the UV light that is more intense is also a factor that is favoring the development of this cyanobacteria bloom. Additionally, especially in our region, low turbulence and not vertical mixing of the water in the river, but also in the lake, like in the upper Sur, is definitely not favoring their disappearance. And since we are talking about warm water and the UV light, it's clear that climate change will catalyze the expansion of these cyanobacterial blooms. And it's clear that we have more and more during summer, also because our summers are much, much longer. But why they are a problem? And what are the consequences? So visually speaking, you have a loss of water clarity. The water is nicely green, but it's not so good because it's also there is suppression of aquatic macrophytes, so plants that are living in our ecosystem. The presence of these blooms is also negatively affecting the life of invertebrate and fish. Why? Because there is oxygen depletion. So there is much less oxygen available for the species in the aquatic ecosystems. And these are the problems related to the environment. But why then we have a ban? Why we cannot bat in the sewer? Because cyanobacteria can also produce secondary toxic metabolites like cyanotoxin, which can be, when they are produced, can cause mild or serious illness if we, for example, are in contact with these waters, like human. And this is the reason why we get the ban and we cannot have our nice swim in the Upper Sur Lake. Why we are here? So Jean-Baptiste and List, in general, they are working in the surveillance, the awareness and the monitoring of the cyanobacterial blooms since 20 years. They have several initiatives like a mobile app, several projects together with the Administration de Gestion de l'Eau. They implemented surveillance programs to really monitor the water and see when this blooming are arriving in a way that the decision makers can also implement the right measures to prevent illness, for example, if we are in contact with this water. And why I am here? I'm an engineer, so I work in the Department of Engineering at the University of Luxembourg. And since 15 years, I'm working on the prevention of pollution, especially pollution that comes from the human activity. So when we go back to the factors that are favoring the development of cyanobacteria, we are speaking about especially the release of the nutrients. So as an engineer, we could somehow reduce control the discharge of the nutrients remove or to decrease, to mitigate the possibility of this cyanobacteria to bloom. We just got an Interreg project, which is called QualiSure, and it will last for 3 years. And it is a project that is partially funded from a regional fund of the commissions and partially from the Administration de Gestion de l'eau, which wants to preserve the quality of the Sur lake, and which is also the lake where the blooming is often appearing. And why that? Because the Sur lake is beautiful, as you see. It's one of the most beautiful places where you can swim and bath in Luxembourg, but it's also very important because it's the biggest reservoir of Luxembourg, providing 43% of the annual consumption of drinking water. So it's really, really important to reduce as much as possible the pollution. What we want to do is to identify hotspots of pollution to really preserve the quality of the water. And the second step, once these hotspots of pollutions are identified, we want to introduce a nature-based solution to mitigate the emission of this pollution. What are nature-based solutions and why I'm today speaking about that? So we are considered experts at the university in this technology, which are called nature-based solution because it's like a little ecosystem where you have a substrate that is mainly soil and you have a plants. And the action of plants and the substrate and the living organism in the soils are helping the removal of any pollutants. We were securing about 3.5 million of external funding to develop our competencies in nature-based solutions since 2017. The main advantage of these technologies is that they are really effective, sustainable. And if you think about the landscape of the Sur, they can fully be integrated in the landscape. So the idea is to identify this hotspot of pollution and to implement a nature-based solution to mitigate the emissions of nutrients and any kind of other pollution in the Sur lake. And why I said that we should join the force with the list. And Jean-Baptiste is a microbiologist, or they are expert in microbiology. We are engineers. Our competencies are different, but I think we can really match together. Just recently, there was an evidence in the literature that a nature-based solution can be used to reduce the cyanotoxin present in any water stream. So I see here a lot of points in common that we can explore and we can discuss. So this is just a short introduction about the topic and how this can be matched with the competences of the University of Luxembourg. And now I will give the floor to Jean-Baptiste.
Thank you very much, Silvia, for the kind introduction and also for the introducing this subject. Thank you, Mathieu, for teasing already that it's not an algae.
Sorry.
So I can remove a lot of things from my talk. No, I'm kidding. It's fine. No, it's important to know because actually it's often a mistake that we do. But anyway, it doesn't change anything about the problematic of cyanobacteria. I mean, that's not so. It's just a terminology, let's say. So I'll start to share my screen if I manage to do that. Share. Okay. Okay. So do you see my screen? Do you see my screen?
Yes.
Yeah. Okay, perfect. Good. And it's in full screen, right? Okay. Okay. So there will be a couple of things that Silvia addressed already. I will not go too much in details, but I will give you some idea here about what I'm going to present. So defining a bit what are cyanobacteria or blue-green algae. call them also BGA for blue-green algae, is maybe easier and shorter, causes and impact of cyanobacteria blooms, and then how can we deal with them today in the changing world? What can we do to protect public health and also to protect the ecosystem in general and mitigate those blooms in the long term? So starting with more a definition of what are cyanobacteria, here's a bit an ID card of them. So cyanobacteria are actually prokaryotic microorganisms, so without cell nucleus, so they are unicellular, typically bacteria. They are actually photoautotrophic, which means that if you look at here at the phylogenetic tree of life, you see cyanobacteria really here among the bacteria, and algae here on the right is really at the opposite. So it's definitely not an algae, but they are capable of doing photosynthesis, and that's why also we confound them with algae. So here also you see this cell structure, no nucleus. That means that they are prokaryotic microorganisms. They are doing photosynthesis, so they're converting sunlight into to produce their energy actually, and using carbon as a source, CO2 as a carbon source to get their to do the entire metabolism of their cells. They're also capable of capturing the atmospheric nitrogen, which gives them a significant advantage, competitive advantage compared to other phytoplankton communities, and that's why also they can bloom in certain circumstances, also in marine environments. It's a really diverse group, and they are really found everywhere on the planet. More than 2,000 species that are known, marine species, but also freshwater species. Here we are more, of course, dealing with freshwater species. And all these blooms you're talking about are mainly in lakes and reservoirs worldwide, so freshwater resources. You can also find benthic cyanobacteria, so they are really attached to the ground, to the sediments, and they can also bloom on the sediments, versus planktonic, so free-living cyanobacteria in the water column that are then, this is what we know, they are forming those blooms at the surface of the water. So you can see here that really diverse forms, morphologies, filaments, different way to different forms of these cyanobacteria. They are found in colonies typically. That's why they also can aggregate together and then form these large blooms. We are now talking a lot about cyanobacteria for what they are causing. In terms, they are harmful, and actually they are threatening public health through their toxin release and ecosystems health. But we shouldn't forget that they are actually at the origin of life. If we are here today to speak together, it's also thanks to them, because they have contributed significantly to increasing the oxygen level in the atmosphere up to 21% of today. 3 billion years ago, they started to do the photosynthesis, oxygenic photosynthesis. So the increase in oxygen has been steady, and until today, 21% of oxygen in our atmosphere. And you see then the land plants, terrestrial animals, and finally we also as humans. So they have been on Earth for quite a while, and you can also see this on fossils. They call these stromatolites, this kind of the ancient cyanobacteria that are fossilized, and you can find some very old rock formations on Earth. They're also really quite outstanding chemists, because they produce a large diversity of bioactive compounds. Now, the scientific community is looking more and more into it, because we can really find interesting compounds for health, and also so antimicrobial, antifungal, anti-inflammatory properties. We know maybe the best of them. We know also food supplements with spirulina. You can see here on the right, it's actually a cyanobacteria called Limnospira. But you can see they can really produce a large amount of compounds, and among them, with scophores, we find the cyanotoxins. But there are also many other compounds that can be very beneficial for us. As I said, they can bloom. Unfortunately, they can bloom, but it's not a new phenomenon. So I will explain later on that the human activities are really fueling this phenomenon, as also Silvia already mentioned. But the harmful cyanobacteria blooms occurred early on during hundreds of thousands of years in Pleistocene and Eocene, so in geological times. There's a paper here that I've been describing a really well-preserved community of fossils of animals. So in the Eocene, I don't remember exactly how many hundred thousands or millions of years ago, but anyway, it's more recent than to our times now, and it's in a lake in Germany, and they found actually elements that could indicate that these animals were died because of a large bloom in that lake following ingestion of maybe toxins or whatever. So there are some indications that the blooms have occurred early on, and also very clear historical references to cyanobacterial blooms by Darwin or also by other explorers like here Trichodesmium that can occur in the Red Sea, also in the Caribbean Ocean. So they can form marine blooms also that have been already observed some time ago. But unfortunately, with the let's say unsustainable use of our natural resources and pollution, the blooms have been increasing, and in general, not only cyanobacteria, but in phytoplankton, so also algae in general, have been increasing worldwide over the last decades. Here, it's a nice paper from a recent paper that is showing with Landsat images. They used like 3 million Landsat images between 1982 and 2019, and they have looked at the bloom occurrence for each lake they have studied. I think there were more than 300,000 lakes worldwide they have studied with these images, and they show how the increase in occurrence, the increase in occurrence between decades. So here the first image is between the 90s and 2000s, and then here between 2000 and 2010, and you really see that the large increase have been occurring in terms of bloom frequency during the 2000s and 2010. So, and you can also see mainly in Asia and also, of course, in Africa, but really mainly in Asia. That shows also that many of these countries are, let's say, more in a developing countries, where also there is a lot of pollution of natural resources, and this definitely contributes to the rise in these blooms. You can see a picture from a lake in China, and below it's actually the Lake Erie. Lake Erie is one of the large lakes in North America, and this is really a huge bloom that you can see on a satellite image. So what is it causing and the blooms, and what are the impacts of those blooms? As I mentioned now before, it's mainly because we are polluting our natural resources, and you can see here with the planetary boundaries, the most recent one, that we are far exceeding the barrier geochemical flows with phosphorus and nitrogen. And these nutrients that are released by agriculture, but also municipal sewage and industrial activities, they are accumulating in our water resources, in rivers, lakes, and so on. And they are actually causing what is called eutrophication. Eutrophication is the enrichment of natural resources, natural water resources, in nutrients. So you start with an oligotrophic stage with clear nutrient poor system, and then if you add too many nutrients over time, it becomes mesotrophic and then eutrophic, with really consequences on the communities and also on the clarity of the water and on many other properties of these water bodies. And cyanobacteria are actually a symptom of eutrophication. So typically, cyanobacteria blooms, they will occur if there is abundant light, high temperatures, high pH levels, and very important, if the water is stagnant, that's really really contribute to the blooms. And of course, you need an excess of nutrients. So these are the environmental conditions, but the source of excess nutrients, as I said, are coming from anthropogenic activities, and climate change is fueling this phenomenon. It's really aggravating this phenomenon, because water temperature, air temperature increasing, we have more extreme events. Extreme events means that if it's raining, the temperature of the water will maybe decrease temporarily during summer, but it will also contribute to the runoff nutrients from feeds and so on that will then come to the rivers and to the lake and add nutrients to the lake and to the sediment of the lake, and potentially contributing to the maintenance of these blooms. Of course, there are large impacts. There are some really well-known cases like Lake Tayu in China in 2007, but most known is in 2014 in USA, the Toledo water crisis, where hundreds of thousands of people who were not able to drink the tap water because of contamination by a bloom. Cyanotoxins were found in the water, so they had to have a boil water advisory, and they were not able to drink their water from the tap. So you can say again here, like the previous picture I showed you, this is again Lake Erie, and you see the city of Toledo on the left, and really a huge bloom that is occurring there. Also very well-known lake for blooms in the USA. And some studies have assessed, but of course it can be much higher. But we're talking about billions of dollars in terms of cost of these algae blooms in general. As I said, they are producing toxins. So this actually is threatening public health, and this is why also I will talk about it later. We are monitoring our recreational areas here in Luxembourg to protect beachgoers and bathers from potential release of toxins when there is a bloom. There are a variety of toxins, hepatotoxins, cytotoxins, neurotoxins, and also dermatotoxins. So what usually happens is that some people that are exposed to cyanobacteria or to a bloom, have been swimming into a lake with a bloom, they might have some rash, they will have, through dermatotoxins, they will have some, I don't find the word, but anyway, impact of dermatotoxins on their body. Much less frequent is intoxication by hepatotoxins or others. There are really very few and rare cases of acute exposure, but it's more for animals like dogs and also some cattle, but these are more exposed to them, and you regularly hear in the news that some dogs have died or have been intoxicated by after drinking in a lake where there was a bloom. So, but for humans, we don't necessarily know what is the long-term exposure. So that's something more difficult to assess. There are really very few, if not very few, studies on epidemiological studies on this, and it's very complicated to study. So we don't necessarily know the long-term effects, and so we should also be precautionary and try to avoid exposure to these toxins. There is, of course, not only an impact on the humans, but also on the ecosystem. There are some cascading effect, and also on the entire communities where toxins will have an impact, but also the blooms themselves by oxygen depletion. When they are dying off, the oxygen will deplete, and this will cause a die-off of fish and other organisms. So there are a lot of impacts of those blooms on the ecosystem and on our health, potentially on our health and on the health of our pets. So knowing this, what can we do with those blooms? Because we know they are occurring every year. They're coming back every year almost. And with climate change, it might increase even more in some areas of the world, including here in Luxembourg. So there are different solutions. There is no one solution fits all. But first of all, we have to assess and control the risks related to the blooms. And also, first of all, limit the nutrient loads from the catchment. So that's one first thing to do. There are ways to do that. To determine, first of all, to know our catchment. Well, what are the pollution sources? What are the nutrient concentrations? And then estimate critical nutrient loads to reach a target to decrease this nutrient load input in the catchment. We also need to know the water body conditions. We need to better know what our lake is, what are the parameters of our lake, and for this there are really key parameters to follow, like total phosphorus, which is one of the limiting nutrients, the mixing conditions. I was talking about stagnant water, so we should know how stagnant are the lake, in what conditions during summer, how does it behave in terms of hydrodynamics, transparency of the water, and pH. And you can see that if these parameters are in the range of those like low transparency, pH above 7, then we are really at risk for cyanobacterial bloom. So first thing is also to know our water body, to know our catchment well, to be able to determine what is the risk, and then to be able to take actions to manage that risk and control it. So how to control the risk, how to potentially mitigate the blooms and on the short term, but also on the long term. So there are a variety of solutions that should be then fitted to the specificities of the lake and of the catchment. Not everything works everywhere, of course. Hydrophysical control of growth conditions, for instance. So you can try to de-stratify the lake, for instance. A very good example in Weiswampach Lake on the north of the country, they are using a boat and they're trying also to circulate around the lake when they see that the lake is becoming too stagnant, so to create some mixing. And this is one way to avoid too much stagnation of the water and stratification, which will then cause the blooms. There are other solutions to remove also the phosphorus, sediment removal, sediment treatment, to remove the phosphorus that's been accumulating in the sediments, sediment dredging, but also sonication, which is part of also hydrophysical control. Sonication has been tested by our team before I came, and it was not conclusive because in the Upper Sur Lake, for instance, there is still some movement in the water column. It's not a typical lake. There is movement. It's a river that has been dammed, and even in summer, the movement of the water mass is still, there is still movement. So if you put a sonication device in the water, it has a very limited range, and because of the moving water, it was not conclusive. So in some very small ponds, it can work, and those commercializing these sonication devices are really advocating this, but for small ponds. If you go in a larger scale, it's more difficult, and there are papers showing that it doesn't really work. So it's really important for a manager to know what is working, what's not working, because it can be very expensive solutions to test. There are some biological controls, also with biomanipulation of lakes that is been tested by scientists. Well, this is of course something that is also sometimes risky. There are some viruses like phages that can also kill actually cyanobacteria. But it's also something that is that has really to be then controlled, because it's much more complex solutions. And then of course chemical control like algicides, growth inhibitors, where then you really put some chemicals into the lake, into the water body to settle the cyanobacteria or to lyse them. Like here, a system for clay removal of harmful algal blooms. So they are dispersing some clay in the water body to flocculate the blooms, but then they are depositing in the sediments. But then they're in the sediments, and then we have to remove these sediments also. So it's not necessarily the best solution to do. And of course, if you're talking, for instance, like the Upper Sur Lake here in the north of the country, which Silvia said is providing almost 50% of drinking water to the country, you cannot just do anything like this in such a crucial drinking water supply. So for drinking water, actually, how do we do to minimize the risks? Example again for the Upper Sur Lake, that is abstracting the water from the lake to produce drinking water and distribute it to the whole country. Well, there's a multi-barrier approach to reduce the risk. Among these multi-barrier is part of it is prevention and source control. And here you can see on the right the map where the catchment of the Upper Sur Lake is being managed, and the protection zones have been defined, and they have been recently enlarged to really protect more and more the lake and ensure that the nutrient load is being reduced over the years. So it's also important to know that this is really multi-stakeholder actions that really involve the agriculture, natural reserves, the drinking water utility, the government. So it's really a common action that needs to be implemented to tackle this major issue of nutrient inputs into the lake. Then, this has been in 2021. The protection zones have been enlarged for the Upper Sur Lake. Then, of course, optimize the treatment here. And for instance, the CEBES has been inaugurating recently their new treatment plant that is capable of removing or even more micropollutants and many emerging pollutants. For cyanobacteria, they could also better remove than cyanotoxins, although this was already the case before. The risk is more for the clogging of filters if there is a major bloom. But I didn't find the picture here, but there is a ProVar. It is this device that is capable of abstracting the water at different depth of the lake. They can adjust this arm in the lake that is taking the raw water from the lake, and in case of blooms, they are adjusting the depth of this arm so that they always take the cleanest water in the lake before it goes to the treatment plant. So that's a really useful solution to already get the cleanest water from the lake before treating it. Then beside these treatment options and mitigation actions, of course, we cannot implement them, all of them, and many of them, and the most, let's say, convincing one are probably those that are on the long term, and we will see the results on the long term for nutrient load reduction, for instance. And so we do have then to deal with these blooms that are occurring every year. So how to deal with it? We have to control the risk for public health and to monitor those blooms, cyanobacteria blooms and toxins. And at least here we are doing it for more than 20 years, mandated by the Water Management Authority. And we are now, since last year, we added also Echternach Lake because it's now an official bathing area. We are monitoring these different water resources, the Porcio Lake, Weiswamper, Remerschen. The Moselle River is not an official bathing site, but it has been impacted by blooms in the last years. So we're also monitoring it to know what's happening on this recreational river also. So these are some pictures from blooms in the Upper Sur Lake that are occurring almost every year. And why are we doing this? Because there is a regulation behind, of course, the EU regulation with the Bathing Water Directive that asks to monitor this cyanobacterial risk. And if there is cyanobacterial proliferation, it should be shown by appropriate monitoring. So it's not detailed at all. It's just saying you should monitor your bathing waters, and then you should take the adequate management measures. But it's not saying how to do it. So every country or every state is doing it a bit their own way, but there is some agreement on it. So we have here a national cyanobacteria alert plan that is based on the one of the WHO and also from other countries or communities. And it's a tier-based approach to assess the risk. So informal decision tree. So we're doing routine surveillance starting in May, June on a bi-monthly frequency. And we go to these bathing sites and we do visual inspection. So is there any algae proliferation? Yes or no? If yes, then we're determining if it's cyanobacteria. Now, if we know that if we see something, we are almost sure it's cyanobacteria, even without looking in the microscope. But if we want to know what species has been blooming, then we're checking on the microscope. If it's a cyanobacteria bloom, we are categorizing it into 3 categories. The category 3 is really the thick layer on the surface. Then we definitely need to close a beach. I mean, we're not doing it, but the Water Management Authority has the competence to close the beach, and we're providing the information to them. So it's an alert. If it's category 1 or 2, so less dense blooms, but still a presence of cyanobacteria in the water, then we're measuring the toxins. And if it's below a certain threshold, we are in a pre-alert. If it's above a certain threshold, we are in alert. We also need to close the beach. So this is the tier-based approach that we are adopting to monitor and control the risk for public health. And then if there is an alert, then of course it's communicated to the public, and Water Management Authority is publishing it. They are doing a press release, and then the national press is taking over this. And as Silvia showed before, you can find information in journals, in the websites of the different media. We have been testing also integrated monitoring approaches with different tools. I see that the time is flying, so I will do it rapidly, just to show you that we have trying different technologies let's say to increase the data flow, because we're going at best once a week on these different sites, but a lot of things can happen within 1 week. So as this is a very heterogeneous phenomenon in time and space, we really need to have more data to better understand the phenomenon and to better assess the risks. So that's just to show you that if you can test it, different technologies with in situ sensing, with probes that are on board in the lake, measuring continuously some key parameters. We're using satellite images to also have an idea on how the bloom are looking like across the entire lake. We have been using some drones to also map some critical areas in the lake. And then what I wanted to tell here before I'm finishing is that we have this CyanoWatch project, which is aiming at involving more the community and going to a more participatory approach using a mobile app. And this mobile app, it was already existing. We didn't want to reinvent the wheel, so we joined our existing project. It's a European initiative, and there are several countries participating to it. And so this blooming algae app can be downloaded for free and it can be used. And last year we used it for the first time. We had like more than 50 reports over the season, where people had pictures and reporting some observations, and we received information and we then can assess it and confirm if it is a bloom or not, or if it's potentially a bloom if we cannot confirm. So we can find on cyanowatch.lu on our website, you can find this interactive map with the different reports over the season. And we organized a small contest last year to also incentivize people to send their reports, and so with 4 winners of this contest last year. So it was really fun also to work with those people. And I hope it's going to continue this year and even more than last year. So as a take-home message, I wanted to stress, because we had the Sustainability Lunchtalk, so cyanobacteria blooms, I wanted to stress on that, is really a symptom of unsustainable management of our natural resources. If we look at the SDGs here, it's touching really at different of these SDGs, 6, 11, 13, 14, 15, and maybe also on others indirectly. Climate change is definitely fueling this phenomenon worldwide, and there is no single solution to tackle this major problem. It's risk monitoring and control, but also mitigation. As I said, it's not a solution that fits all. I mean, it's not a single solution. It's really a solution that depends on the specificities of each water body and each catchment and context. So thank you for your attention, and I would like also to acknowledge all my colleagues from the team who have been working on cyanobacteria before I came, also the Water Management Authority and the CBS, with whom we really collaborated a lot, and thank you for your attention.
Thank you very much, Jean-Baptiste. Super interesting. I had a set of questions, but I think I got even more in my mind. Maybe I can start to ask some questions, and then if the audience wants to ask questions, can follow me up. Mm-hmm. I have one simple question. So imagine we have a blooming. How long it lasts until the bacteria are dying?
Good question. Yeah, that's a good question. Usually what we see, if it starts to bloom, that means really a large bloom visible on the surface, and so it means a significant biomass that is visible at the surface of the water. It will stay 1-2 weeks, maybe a bit more, depending on the conditions. It depends a lot on the wind conditions, on the mixing conditions, on the sunlight. But even if you have the best conditions and to maintain that bloom, at sometimes it will have depleted the resources, the nutrients. It will be also too many microorganisms. They will compete to each other, and it will eventually die off, and then release potentially also toxins, so other things. But typically we see this, if it stays, if we can also have a succession of blooms. Like last year, what we did for the first time, that we reopened the beach in the Upper Sur Lake, because we had a first bloom early September. During 1 week, 10 days more or less, then it became a bit colder, a bit more windy, and we really saw a disappearance of the bloom. And during 2 successive weeks, that's why then we decided to reopen. And then it became again good weather and then hotter at the end of September. And then we had to close really before the end of the season. We had to close again just to Romvis, so at the upstream of the lake, not the entire lake, because it was only Romvis that was concerned, the more vulnerable beach in the lake. So we tried to be more dynamic, and that's also maybe follow-up of your question is, how can we be also maybe more dynamic in the management? Because if there is a bloom, should we close for the end of the season? And that's what we're trying to avoid, because we would like to have something more dynamic, but also being conservative and preserving public health.
Yes.
So it's really a trade-off that we're trying to tackle and do our best, but to be more conservative also in protecting public health.
And the dead mass, it's dangerous or not?
The what? Sorry.
The dead mass when they die, no?
Yeah. They die, yeah, but they die because then they die by themselves, because then they have consumed the resources in the water, and there's some competition, and they will eventually die off and settle down, and yeah, so if the weather becomes
biomass will settle and we don't do anything.
Yeah, at the end, anyway, because at the end of the season, we usually see the blooms in September, also lasting a lot in October, but then the season is already finished, the bathing season. But in October, we see large blooms, but then the water becomes colder also. And that's not suitable for them, that they cannot maintain under these conditions, so they have finally die off. And we see typically that end of October, early November, they have died off, and there is almost nothing anymore in the water.
And one question is more engineering related. Well, I see a lot of interface because at the end, the bathing directive is driving, but there's also the drinking water directive in the case of the Sur Lake. But if we look about the emission of phosphorus and nitrogen, then you think that there is the new regulation is also cutting down the emission discharge limits for total phosphorus and total nitrogen. You think that this will help a bit to maybe to decelerate the blooming?
Yeah, I think if you can cut off, I mean, if you can really minimize the releases from point pollution sources, but also from diffuse pollution sources, that's always one direction to go. I mean, that would be definitely the direction to go. And any regulation that is limiting these inputs is useful, not only for the blooms, but in general for eutrophication. And blooms is one of these symptoms of eutrophication, but there are many others.
Yes.
I think also that the difficulty here is that we need to assess this on the long term, and we cannot see a direct, I think, impact on these mitigation actions. And the problem is that these may be also counterbalanced by climate change, which this climate change is fueling the blooms, and we are trying to actually decrease the probability of blooms by removing the substrate, the nutrients, actually. So that's why we should definitely do it in the long term also. But we know that climate change will also counteract this. That's why it's even more important to limit the nutrient inputs into the lakes.
And what do you think? I mean, if there would be like a competition between the nutrients and the climate change?
It's hard to say. It's really hard to say, and it's really dependent on every lake or water body catchment. It's very specific, I guess, because in what I read from scientists is that in some areas it will increase, but climate change will potentially also lead to a decrease in some very specific areas. So it's not, I think, that climate change will definitely everywhere increase blooms, but it might be in some situations decreasing it. Or it is interesting to see that in 2022. We had a very dry and hot summer, and it's the only year for now more than a decade that we didn't have to close the beach on the Upper Sur Lake because there was no cyanobacterial bloom. It was an extreme event. It was really hot and dry during the summer, and it only rained in September. And then from then on, bloom started late September, early October, so very late. And the bathing season was finished already, so we didn't have to close. So I think this really dry and hot summer can be potentially seen as a consequence of climate change, but you see that it actually led to an absence of bloom because probably of a competition with green algae at the early summer or any other factors. It was too dry, too hot. And it's only when it started to rain in September, then the blooms started on, but very late. So it's very complex, and you cannot say that definitely this will lead to blooms, but there are some global trends actually.
And we have a question from the audience, from Fadi. Could a controlled cyanobacterial culture help clean up water resources and fight the climate change by sequestrating CO2?
Clean up the water resources and fight climate change, basically. I know that there's some research going on this. I'm less aware of this, but also for biofuels, I know that algae in general and cyanobacteria could be a potential solution, but these are still pioneering solutions. I guess we are not there yet, I think, and we have been thinking of how could we valorize this biomass actually. If the blooms are there, we cannot get rid of them. Can we then maybe valorize them? Well, we're not thinking about sequestering CO2 here, but we were more thinking about using them as a biomass to be converted and to be used for producing heat, for instance, with other biomasses. But we didn't get that project running finally. But there are also potential other ideas in using these biomass to extract some metabolites. At the beginning of my talk, I was talking about these metabolites that can be useful for human health and in general for our societies. And a lot of research is being done here. And why don't we use those blooms to really do more research on studying these metabolites and extracting them and potentially using them for producing useful compounds for humans. Yeah, there are many potential solutions for this.
Thank you very much, Jean-Baptiste, Silvia. I'm sorry we're running out of time. The technical issue got us. We lost a few minutes at the beginning, but I would like to thank you both for your insights and expertise on this topic. We hope you all enjoyed the presentation and the discussion. Once again, it will be made available online during the week, so you can share it with other people who could not attend today. Before closing this WebEx and closing this season of the Sustainability Lunch Talk, I would like to invite you already to our next Lunch Talk. It will be on 2nd October, and the subject will be on supply chain and logistics with Professor Joachim Arts from the Faculty of Law, Economics and Finance. We will soon announce the program for 2024-2025, so stay tuned. Visit our webpage, sustainability webpage on the university website to find all the information, or subscribe to our letter if you want to be informed of the coming lunch talks. And finally, once again, thank you very much, Jean-Baptiste. Thank you very much, Silvia. You see, Jean-Baptiste, it's been a year since we've been talking about this talk. Finally happened. And now you can go and fight algae. You can go outside.
Let's see what will happen this summer.
Yeah, it's can never say. Never can say.
Hopefully a bit of sun,
curious.
please, at least.
Hopefully.
No, thank you very much, and wish you all the best. Have a nice day.
Thank you very much.
Thanks to you.
Thank you. Bye-bye.